Last part ನಲ್ಲಿ S block elements na alkali metals ನಲ್ಲಿ elements belonging to alkali metals, occurrence, electronic configuration, atomic radii and ionic radii, ionization enthalpy, hydration enthalpy, ಹಾಗೂ physical properties, chemical properties, uses, general characteristics of alkali metals, ಮತ್ತೆ anomalous behavior of lithium and how lithium is different from other members of that particular group, diagonal relationship between lithium and magnesium, ಹಾಗೂ some important compounds of sodium. ಅದರಲ್ಲಿ ನಾವು sodium carbonate, washing soda ಇಷ್ಟನ್ನ ಕಲಿತಿದ್ದೀವಿ. So I welcome all of you again to the second part of the S block element. Now ಇವತ್ತು S block element na some important compounds of the sodium na other compounds na ನಾವು ಇವತ್ತು ಕಲಿಯೋಣ. We have learned sodium carbonate decahydrate, that is washing soda. It's manufacturing by Swabodha process. The second compound of the alkali metals that we have taken is sodium chloride, that is NaCl. We know that sodium chloride is present in seawater. The percentage of the sodium chloride in seawater is between 2.7 to 2.9% by mass of the solid. When seawater is evaporated, it yields the crude sodium chloride. Crude sodium chloride. This crude sodium chloride contains impurities such as calcium sulfate, calcium chloride, sodium sulfate and magnesium chloride. Of course, calcium chloride and magnesium chloride that are undesirable component present in the seawater, and they are even deliquescent also. For purification, the crude sodium chloride solution is taken up and the insoluble impurities are removed. Then the solution is treated with HCl gas. Due to common ion effect, sodium chloride crystallizes out, whereas calcium chloride and magnesium chloride that they are more soluble in the solution remains in the solution itself. What are the properties of the sodium chloride? Sodium chloride is a white crystalline solid. Its melting point is 1081 kelvins. Its solubility is, when you take 100 grams of water, 36 grams of sodium chloride dissolves at 273 kelvins. What are the uses of the sodium chloride? Sodium chloride is called as common salt. Therefore, it is used in the domestic purpose, and also sodium chloride is used in the preparation of the sodium hydroxide, sodium peroxide, sodium carbonate also. The third compound that we are studying under sodium is sodium hydroxide. Formula is NaOH and it is called as caustic soda. Sodium hydroxide commercially prepared by the electrolysis of the sodium chloride, that is nothing but brine solution, and it is generally prepared in Kastner-Kellner cell. Kastner-Kellner cell. In the electrolysis of the sodium chloride, we are going to take up mercury as the cathode, and carbon is made as anode. So let us write the electrolytic reactions at the cathode and anode. At cathode, sodium ions, it accepts 1 electrons, and sodium metal is deposited on mercury cathode. Therefore, we call it as sodium amalgam. At anode, chloride ion, it loses 1 electron and forms Cl. Chlorine is liberated at the anode. So this sodium amalgam reacts with the water and forms respective sodium hydroxide and mercury and hydrogen is liberated. So here is the reaction. When sodium amalgam is reacted with water, it forms sodium hydroxide and mercury and hydrogen is liberated. So in this way, the sodium hydroxide is prepared. What are the properties of this caustic soda or sodium hydroxide? It is white translucent solid. It is readily soluble in water, and sodium hydroxide solution on exposure to air, carbon dioxide containing in the air reacts with sodium hydroxide and forms sodium carbonate. Sodium hydroxide solid is deliquescent in nature. What are the uses of the sodium hydroxide? Sodium hydroxide is used in soap industry, and it is also used in paper, then silk. It is used in the preparation of the pure fat and oil also. The fourth compound that we are studying under sodium is sodium hydrogen carbonate. Its formula is NaHCO3, called as baking soda. When baking soda is heated, the carbon dioxide liberates. We have seen in bread, cakes and pastries, the holes are present. That is due to the liberation of the carbon dioxide from baking soda, makes the bread or pastries or cakes soft, puffy. Now, how it is prepared? Baking soda is prepared by when sodium carbonate is treated with carbon dioxide and it forms white crystalline powder is formed, that is nothing but sodium hydrogen carbonate, and here is the chemical equation Na2CO3, that is sodium carbonate. When it is reacted with water and carbon dioxide, we call it as the saturating a solution of the sodium carbonate with carbon dioxide, white crystalline powder of sodium bicarbonate that is less soluble separates out. What are the uses of the sodium bicarbonate? It is used as mild antiseptic, especially for the skin infections, and also it is used in the fire extinguishers. Biological importance of sodium and potassium. Sodium ions are found primarily in the extracellular fluids on the outside of cells. These are found in the blood plasma and in the interstitial fluid which surrounds the cells. These ions participate in the transmission of nerve signals, in regulating the flow of water across cell membrane, in the transport of sugars and amino acids into cells, activate many enzymes, participate in the oxidation of glucose to produce ATP, and the sodium and potassium ions together constitutes sodium-potassium pump or sodium pump. The functioning of this pump is a biological process and takes place in each and every cell of animals. This develops electrical potential across cell membrane which is responsible for nerve signals in animals. S block elements ನಲ್ಲಿ ಇಲ್ಲಿವರೆಗೆ ನಾವು ಗ್ರೂಪ್ 1 ಆಲ್ಕಲಿ ಮೆಟಲ್ಸ್ ಬಗ್ಗೆ ತಿಳ್ಕೊಂಡಾಗಿದೆ. ಈಗ ಗ್ರೂಪ್ 2 ಆಲ್ಕಲೈನ್ ಅರ್ತ್ ಮೆಟಲ್ಸ್ ಬಗ್ಗೆ ನಾವು ಡೀಟೇಲ್ ಆಗಿ ತಿಳ್ಕೊಳ್ಬೇಕಾಗಿದೆ. S block elements consists of group 1 and group 2 of the periodic table. Group 1 is alkali metals and group 2 is alkaline earth metals. So let us learn group 2 alkaline earth metals in detail. Alkaline earth metals. Why they are called as alkaline earth metals? Because their oxides and hydroxides are strong alkaline in nature, and also their metallic oxides are abundant in earth crust, or they are found in earth crust. That is why they are called as alkaline earth metals. ಈಗ ಆಲ್ಕಲೈನ್ ಅರ್ತ್ ಮೆಟಲ್ಸ್ ನಲ್ಲಿ ಯಾವ ಯಾವ ಎಲಿಮೆಂಟ್ಸ್ ಇದೆ ಅಂತ ನೋಡೋಣ. ಬೆರಿಲಿಯಂ, ಇಟ್ಸ್ ಸಿಂಬಲ್ ಈಸ್ Be. ಮ್ಯಾಗ್ನೀಷಿಯಂ, ಸಿಂಬಲ್ Mg. ಕ್ಯಾಲ್ಸಿಯಂ, ಸಿಂಬಲ್ Ca. ಸ್ಟ್ರಾನ್ಸಿಯಂ, ಸಿಂಬಲ್ Sr. ಬೇರಿಯಂ, Ba. and radium are beryllium, magnesium, calcium, strontium, barium ಮತ್ತು ರೇಡಿಯಂ. ಇದರಲ್ಲಿ beryllium is little bit different from the other elements of that particular group, and also beryllium shows diagonal relationship with aluminum. ಈಗ ನಾವು ಅದರ ಅಕರೆನ್ಸ್ ಬಗ್ಗೆ ತಿಳ್ಕೊಳ್ಳೋಣ. ಅಕರೆನ್ಸ್ ಆಫ್ ಆಲ್ಕಲೈನ್ ಅರ್ತ್ ಮೆಟಲ್ಸ್. ಕ್ಯಾಲ್ಸಿಯಂ ranks 5th in the earth crust. Magnesium ranks 5th in the earth crust. Strontium and barium are in lower abundances, and beryllium is rare, and radium is radioactive element. Radium, radioactive element. ಈಗ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಬಗ್ಗೆ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡೋಣ. I have represented with the help of EC. The general electronic configuration of the alkaline earth metal is represented as noble gas Ms2. S orbital contains 2 electrons in the outermost orbit, or S orbital contains 2 electrons. So let us learn the electronic configuration of all the alkaline earth metals, that is group 2. Electronic configuration of group 2 elements, that is alkaline earth metals, is according to the table. It's like this. Element beryllium, atomic number 4, its electronic configuration 1s2 2s2 or helium 2s2. Magnesium, atomic number 12, electronic configuration 1s2 2s2 2p6 3s2 or neon 3s2. Calcium, atomic number 20, its electronic configuration 1s2 2s2 2p6 3s2 3p6 4s2 or argon 4s2. Strontium, atomic number 38, its electronic configuration 1s2 2s2 2p6 3s2 3p6 3d10 4s2 4p6 5s2 or krypton 5s2. Barium, atomic number 56, its electronic configuration 1s2 2s2 2p6 3s2 3p6 3d10 4s2 4p6 4d10 5s2 5p6 6s2 or xenon 6s2. Radium, atomic number 88, its electronic configuration 1s2 2s2 2p6 3s2 3p6 3d10 4s2 4p6 4d10 4f14 5s2 5p6 5d10 6s2 6p6 7s2 or radon 7s2. Atomic and ionic radii of alkaline earth metals. Atomic and ionic radii of the alkaline earth metals are smaller than those of corresponding alkali metals in the same period. This is due to increased nuclear charge in these elements. The atomic and ionic radii increases down the group. Ionization enthalpy. Alkaline earth metals have low ionization enthalpies due to fairly large size of the atoms. Since the atomic size increases down the group, their ionization enthalpy decreases. The first ionization enthalpies of the alkaline earth metals are higher than those of the corresponding group 1 metals. This is due to their small size as compared to the corresponding alkali metals. The second ionization enthalpies of alkaline earth metals are smaller than those of the corresponding alkali metals. This is because by losing an additional electron, these elements attain the stable octet, that is noble gas configuration, and therefore they have ready tendency to lose electron. Hydration enthalpy. Like alkali metal ions, the hydration enthalpies of alkaline earth metal ions decrease with increase in ionic size down the group. Be2 plus is greater than Mg2 plus is greater than Ca2 plus is greater than Sr2 plus is greater than Ba2 plus. The hydration enthalpies of alkaline earth metal ions are larger than those of alkali metal ions. Thus, compounds of alkaline earth metals are more extensively hydrated than those of alkali metals. Example,
MgCl2 exists as MgCl2.6H2O, CaCl2 exists as CaCl2.6H2O, while sodium chloride and potassium chloride do not form such hydrates.
Let us discuss the physical properties of the alkaline earth metals. Usually they are silvery white metal, lustrous and relatively soft. But beryllium and magnesium are somewhat greyish in color. Alkaline earth metals are harder than alkali metals. The melting point and boiling point of the alkaline earth metals are higher than the corresponding alkali metals because of their small size. Alkaline earth metals are having low ionization enthalpy. Because of this, they are strongly electropositive in nature. Electropositivity increases down the group. Calcium, strontium and barium impart characteristic color to the flame. So calcium, it gives brick red color. Strontium gives crimson red. And barium, apple green. In flame, the electrons are excited and they go to the higher energy level. When they drop back to the ground level, the energy is emitted by the absorption of light. In beryllium and magnesium, the electrons are strongly bound by the nucleus. That is why they do not get excited when we subject it for flame test. In alkaline earth metals, they are having high electrical conductivity and as well as thermal conductivity. Calcium, barium and strontium, they impart characteristic color to the flame. Calcium gives brick red flame, strontium gives crimson red flame and barium gives apple green color. So let us see the flame test of these metals compounds when it is subjected for the flame. I have taken calcium carbonate. I have made a paste of calcium carbonate with concentrated HCl. Now I am subjecting this calcium carbonate paste to the flame. Since calcium is present in the salt and absorb the flame, it is brick red color flame is obtained. The next metal that undergoes flame test in the alkaline earth metal is strontium. We have taken strontium chloride. It contains strontium in it. When strontium chloride is mixed with concentrated HCl and this paste is subjected for flame test, the next element of the alkaline earth metal which imparts color to the flame is barium. I have taken barium chloride. In this, barium is present. When we subject it for flame test, it produces. Let us move on to the chemical properties of the alkaline earth metals. First one, reaction with air. Alkaline earth metals. In alkaline earth metals, beryllium and magnesium are inert to oxygen. But beryllium in powder form, when it is subjected for oxygen, it burns brilliantly and forming respective oxide and nitride. That is BeO, beryllium oxide, and Be3N2, beryllium nitride. Magnesium is more electropositive in nature. When it is subjected for oxygen, it burns dazzling brilliant and forms respective oxide and nitride, that is MgO and Mg3N2. Magnesium nitride and magnesium oxide. Other alkaline earth metals such as calcium, strontium and barium readily reacts with oxides and forms their respective oxides and nitrides. Second chemical properties, reaction with water. Alkaline earth metals are inert to water because of the formation of oxide film on their surfaces. But the calcium, strontium, barium, they readily reacts with water and forms their respective hydroxides. But only beryllium and magnesium, they are inert to water. Third chemical property is reaction with halogens. Alkaline earth metals, when they react with halogens at elevated temperatures, it forms respective metallic halides, and we can give the formula MX2, where M is the alkaline earth metal and X is halogen. We can give to the chlorine, bromine and iodine. The fourth property of the alkaline earth metals reaction with hydrogen. Except beryllium, other alkaline earth metals they react with hydrogen and forming respective hydrides having the formula MH2. Even beryllium hydride also can be prepared by using beryllium chloride and lithium aluminum hydride. The reaction goes like this. Beryllium chloride BeCl2 when it is reacting with lithium aluminum hydride having the formula LiAlH4 and forms beryllium hydride, lithium chloride and aluminum chloride. This BeH3 is beryllium hydride. The next property is reaction with acids. All the alkaline earth metals, when they react with acids, produces hydrogen. So let us write the general equation for that. M stands for alkaline earth metals. When it is reacting with HCl and it forms respective metallic chloride, Mc2 plus hydrogen is liberated. The sixth chemical property of the alkaline earth metals, reducing nature. Alkaline earth metals are having two low standard electrode potential, indicating that they can go for oxidation easily and also they are highly reducing agent. So the reducing character increases down the loop. Next is seventh chemical property of the alkaline earth metals, that is reaction with ammonia solution. When alkaline earth metals they react with ammonia solution, they form the blue black solution. They form the ammoniated ions and ammoniated electrons. From these solutions, ammoniates can be recovered. So let us write the equation involved in the reactions with ammonia solution. M denotes alkaline earth metal, X plus Y ammonia solution forms MnH3 X So from these solutions, ammoniates having the formula M of NH3 6 times 2 plus ions can be recovered. We have discussed the physical properties of alkaline earth metals and chemical properties of the alkaline earth metals. Now we will take up Uses of the alkaline earth metals. Beryllium and copper alloy can be used for making high strength springs. Beryllium is used for making alloys. Metallic beryllium is used for explosives. Magnesium also can be used for making alloys. Magnesium ribbon or magnesium powder can be used for flash powders as flash powders and also in bulbs and also for signals. Magnesium carbonate is an ingredient for toothpaste. Milk of magnesia, nothing but suspension of the magnesium hydroxide, is used as antacid. Magnesium and aluminium, being light, can be used in air clamps. Barium and calcium, since they readily react with oxygen and nitrogen, it is used to remove air from the vacuum tubes. Radium salts are used in radiotherapy. Radiotherapy is used in the treatment of cancer.
Let us study general characteristics of compounds of the alkaline earth metals. Alkaline earth metals form compounds with di-positive oxidation state, that is M2+. The compounds are ionic but less ionic than alkali metal salts. Because of their small size, higher charge and higher polarizing power, the oxides and salts of small-sized members such as beryllium and magnesium are more covalent than those formed by the heavier and larger sized members calcium, strontium and barium. Let us study oxides and hydroxides. All the alkaline earth metals form oxides of the formula MO. The oxides are ionic in nature with rock salt structure. BeO is an exception. It is covalent in nature. The enthalpies of formation of these oxides are quite high. They are very stable. All these oxides except BeO are basic in nature, while BeO is amphoteric in nature, can act both with acid and base. The oxides react with water to form sparingly soluble hydroxide. The equation goes like this: MO plus H2O gives MOH twice. The solubility, thermal stability and basic character of these hydroxides increase with increasing atomic number from magnesium hydroxide to barium hydroxide. These hydroxides are less basic than alkali metal hydroxides. Beryllium hydroxides react with acids as well as with alkalis because it is amphoteric in nature. Let us see the equation. BeOH twice plus 2OH minus gives BeOH 4 times 2 minus, that is berylate ion. BeOH twice plus 2HCl plus 2H2O gives BeH2O 4 times Cl2. Next characteristic is halides. Alkali metal halides are ionic except beryllium halides. Beryllium halides are covalent and are soluble in organic salts. BeX2 molecules exist only in gas phase at high temperature of the order 1200 kelvins. In the condensed phase, it exists as a polymer in which beryllium is 4 coordinated. Of the other halides, only magnesium bromide and magnesium iodide are soluble in solvents. The tendency to form halide hydrates gradually decreases. For example, magnesium chloride dot 8H2O, CaCl2 dot 6H2O, strontium chloride dot 6H2O and barium chloride dot 2H2O down the group. This is due to increased ionic size, decreased charged density, decreasing the extent of hydration. The hydrated chlorides, bromides, and iodides of calcium, strontium, barium cannot be dehydrated by heating. Magnesium and beryllium chlorides, bromides, and iodides undergo hydrolysis. The fluorides of alkaline earth metals are sparingly soluble in water due to their high lattice energies. Next, we will study salts of oxoacids. First one, carbonates. Carbonates of alkaline earth metals are insoluble in water and can be obtained through precipitation by the addition of sodium or ammonium carbonate solution to a solution of a soluble salt of these metals. The solubility of carbonates in water decreases as the atomic number or cationic size of the metal ion increases. All these carbonates are more soluble in the presence of carbon dioxide in water, forming hydrogen carbonate having the formula HCO3 minus. All the carbonates decompose on heating to give carbon dioxide and the oxide. BeCO3 is unstable and can be kept in the atmosphere of carbon dioxide. The thermal stability increases with increasing cationic size. Next, property sulfates. Sulfates of alkaline earth metals are all white solids and stable to heat. Barium sulfate and magnesium sulfate are readily soluble. The solubility decreases from calcium sulfate and barium sulfate. Magnesium sulfate and calcium sulfate crystallizes in hydrated to form PaSO4.4H2O, MgSO4.7H2O and CaSO4.2H2O. Next characteristics is nitrates. The nitrates are prepared by dissolution of the carbonates in dilute HNO3. Magnesium nitrate crystallizes with 6 molecules of water. Barium nitrate crystallizes as the anhydrous salt. All the nitrates decomposes on heating, giving metal oxide, nitrogen dioxide and O2. Let us see the general formula of this. 2m NO3 twice on heating gives 2MO plus 4NO2 plus O2. Here M represents beryllium, magnesium, calcium, strontium or barium.